Hello, my name is Henna and I'm going to be talking about process wastewater. First, we need to define what process wastewater is. It is water that is used during manufacturing or processing and it comes into direct contact with any raw material, intermediate or finished product, byproduct or waste product. Also, water that is a result of production is also included in this. For example, when starch is produced by an evaporation process that creates condensation water, which is a process wastewater. Process wastewater also includes water that is used to wash plant trucks, product silos, and lines. Large amount of different kind processes use a lot of water and in turn create large amounts of wastewater. In food manufacturing, for example, dairy, meat, alcohol, sugar, and animal feed manufacturing processes are major wastewater producers. In sugar manufacturing, a cleaning process of sugar beets uses large amounts of water as dirt is washed away. Water can also be a byproduct of a process. In the dairy industry, an evaporation process is used to manufacture milk powder by evaporating water from milk. And I'm going to be using food manufacturing as an example in this presentation as my background is in food processing and biotechnology. Also, the food industry has much room for improvement regarding wastewater and its handling. Other industries that have processes that are creating large amounts of wastewater are textile, fertilizer, and mining industries, for example. These processes can produce wastewater from which valuable resources such as heavy metals can be recovered. Where are you going to treat process wastewater that has been created? Number one, you can send it to a wastewater treatment plant, or number two, you can design a wastewater treatment process within your own plant and recycle your own wastewater, which reduces your wastewater output. I believe recycling wastewater within plant processes is the future, at least in the food manufacturing, where a lot of wastewater is created every single day. So I'm going to be focusing more on that in this presentation. How to choose the best way to treat industrial wastewater. You will need to consider the quality of your source water as well as the quality you want after the wastewater has been processed. Different processes, products, and equipment require different quality of water. Testing and treatability studies are a critical step in identifying an appropriate treatment methods. Plant lifespan. How long are you going to use this system? Choosing stainless steel can be expensive over PVC, but in the long run, you'll make up for it by saving on maintenance and replacement costs. And then there are some regulatory requirements. Check out the relevant safety and discharge guidelines to make sure you are complying with them. There are some characteristics in wastewater that you want to treat, such as high BOD and COD level, dissolved and suspended solids, additives, odor and color, chemicals, for example from washing product lines. And these are especially problems with wastewater from dairy product manufacturing. As you already know, process and other wastewater treatment methods depend a lot on what wastewater consists of and how clean we want it. You can use one treatment method or more as a combination as long as it is efficient. You can use different chemical and physical treatment processes that have been chosen specifically for your own wastewater. In chemical treatment processes, there are precipitation, coagulation, and flocculation, different electrochemical and oxidation processes, and as well as adsorption processes. In physical treatment processes, there are flotation, sedimentation, and different filtration methods, for example. And then there is biological wastewater treatment. It might not be suited within the plant itself to process wastewater, as it is sensitive to react badly when conditions change drastically. For example, if a large amount of milk gets in the process, it messes with the microbials in it and causes some trouble with its high amounts of COD. Also, some disinfectants can do this, kill the microbials if it ends up in the process somehow. And here are some combinations I would consider using in treating dairy plant wastewater. You need to remember that wastewater quality can also vary within the plant itself, as there are a lot of different processes. Oxidation, electrochemical processes, and adsorption are used to break down or get rid of particles and get rid of unwanted features, and they are all paired with a filtration method, as filters are designed to remove bigger particles from within the wastewater. Now let's talk about bottlenecks regarding process wastewater, economics and value chain. Processes might be too costly, so it might not even be economically reasonable to clean process wastewater. And when it comes to recovering resources, small amounts and low quality resources are not profitable to recover. There needs to be a market for the resource you are going to provide, so you need to know it, and as well as the competition you are going to have. And in order to sell the resource, you need to know what it can be utilized for. And you can also be innovative with it as long as there is a market for it. Is it still profitable after transport? Sometimes distribution costs are too high. And then there are some bottlenecks regarding environment and health. Some process wastewater and certain treatment processes can react badly and cause health risks and unnecessary emissions. And in society and policy, not everything is accepted by society, and you also need to find out what kind of policies there are regarding your process wastewater and its handling. Some policies regulate the use of certain wastewaters in different kind of processes. So, what can we do to reduce process wastewater generation? 1. We could recycle wastewater within factories and/or processes. This might need some sort of wastewater treatment process depending on wastewater quality. If wastewater was recycled within processes, less wastewater would be leaving the plant and the amount of clean municipal water taken in would be reduced. Number 2. Hot water can be used to heat up processes, and in turn cold water can be used to cool down processes. 3. How would we dispose of or recycle possible sludge left behind? Depending on what it consists of, it could be used to produce biogas. This might be possible to do from sludge left behind from dairy plant wastewater treatment. And also you need to consider if the waste left behind is hazardous or toxic, because it requires different kind of disposal methods. And here are the sources I used in this presentation if you want to check them out. I used the course material of course, and as well as some information I found on the internet. I also have some experience in process wastewater, as I have worked in the food manufacturing for a few years now with it. Thank you for listening to my presentation. If you have any questions or something to note, please leave me a comment.